Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day everyone. Alright, so today we are going to continue with chapter 4. As I said before, this is going to be in this lecture we are going to complete chapter 4. Alright, so during our last synchronous class, Google Meet class, we have discussed about the Fourier Sine series, right? Okay, use it for the interval, as I said before. Okay, interval negative L to L, or meaning to say before this, okay, we have discussed on the Fourier series for specifically period equals to 2 pi. But now we are going to discuss for we have started discuss actually on the Fourier series for the period 2L, where this L can be any number. Okay, meaning that if it is 2L, meaning that the interval for the function is from negative L to L, right? From negative L to L. So that's why we have here, and this one, example 4, we have discussed in our Google Meet class, kan? Alright, so as you know, Fourier series comprise of Fourier Sine series and Fourier Cosine series. So we have done with Fourier Sine series. So now we're going to proceed, okay, for Fourier Cosine series. Alright, so for this Fourier Cosine series, okay, it is mentioned here, okay, the formula for this one, the formula is specifically for Fourier Cosine series of an even function, okay, of an even function, meaning to say this is kita punya formula ni kan, this is how does the Fourier cosine series looks like. But the formula is summation for n equals to 0 up to infinity an cos n pi s over L. Okay, the most important thing is for us to find the coefficient a n. Alright, so different from sine series before, okay, for cosine series we can have to consider two conditions where n equals to 0 and n does not equals to 0. Kenapa yang sine series belum ni, okay, this one we do not consider for n equals to 0, where it started straight away with n equals to 1, okay, because we have here sine n pi s over L, n pi, when n is equals to 0, sine 0 definitely equals to 0. Tu yang kita start from n equals to 1 for Fourier Sine series. Whereas for Fourier Cosine series, you know, when n equals to 0, cos 0 is equals to 1, right? Cos 0 is equals to 1, so that's why we start with a naught. Okay, a naught, or when n equals to 0, we would have the coefficient for a naught, but we do not have for b naught for this coefficient for sine series belum ni. Alright, so the formula for this one is equals to this, and take note on the word here, even function. Kita dah tahu how to get the coefficient a, and here is by finding the integration of the product between fx and cos n pi s over L. So if it is happen that fx is an even function, fx ni even, so we know that cos function is also even, so even function multiply with an even function, it would result to us also even function, kan? Even darab even will give us even function. Likewise, before we have for sine series, odd times with odd, we get even juga. Okay, so because of that, we must simplify the integration. Okay, basically the integration is sebenarnya from negative L to L. Okay, fx darab dengan cos n pi s over L tu. Tapi because this time we are integrating an even function, multiply with cos some more, so it will result still an even function. So you may simplify the integration, become 2 over L integration from 0 to L. Okay, but bear in mind you can only simplify this if given to you the function fx is an even function. Kalau tak boleh lah. Kalau let's say what is given to us same as example 4 sebelum ni. Example 4 the function is an odd function, right? Fx equals to x. So if it is odd times with even, it will result as the an odd function. So we can't use this kind of formula, but instead you have to integrate from negative L to L. Alright, so now let's have a look at example 5. Okay, so in this example 5, the integration that we are to find the Fourier cosine series. So to find the Fourier cosine series, we need to find for A0 and also AN. Okay, for A0, as I said just now, is for n equals to 0. This one for n equals to 1 up to infinity lah. Alright, so here as you can see, we have the formula for AN for n equals 0. So this is the formula for A0. Alright. Okay, so here the formula for A0 is 1 over L integration from 0 to L fx dx, and given to us, lupa nak introduce tadi, our function fx is equals to x square. Okay, so we integrate very simple here because you don't have to multiply with cos because we know cos is equals to 1. Kan? This is for n equals to 0. So we just have to integrate x squared. That's it. Okay, so x squared dx integration from 0 to L. Okay, from 0 to L. So here we have 1 over L. So integrate using normal integration, replace x with L, you will get L square over 3. L square over 3. Okay, and then for n, okay, then the formula becomes, okay, 2 over L integration from 0 to L fx cos n pi x over L. Okay, and here we have 2 over L integration of x square cos n pi x over L dx. Okay, so here, okay, yang ni saya tak tunjuk dia punya integration. Okay, I did not show to you its integration, but as saya dah discuss dalam our Google Meet class before to find the Fourier sine series. Okay, where to solve this kind of integration you may need our kita punya integration by part, right? You need to solve this using integration by part, where the integration here same thing. Okay, tahu kan integration by part, which is u equals to x square, and dv for this one, the remaining in the integration become the dv cos n pi x over L dx. Okay, so you are to integrate, you differentiate u and then integrate dv and so on. I leave it to you to try to solve the integration because this is x square sebenarnya. I reckon you need to do the integration by part twice, and then only you will get this answer. Okay, you should try. Okay, so here we are to substitute. When we substitute the value from 0 to L, then you will get this. Okay, jawapan ni tak complete sebenarnya, so I'm going to discuss with you the final answer for this Fourier cosine series. Okay, so kalau you tengok kat sini, after we replace with all the value here, so we will get here we have n pi, cos n pi, and we have also sin n pi, kan? So the answer that we have given to us here is 2 over pi cube, n cube pi cube 2l square n pi cos n pi. Okay, so let's have a look. N pi cos n pi here, okay, cos n pi here is actually equals to negative 1 power of n. Saya dah explain sebelum ni kan, yang ni kenapa it result cos n pi is equals to negative 1 power of n, because to determine whether it's positive or negative depends on your n. Even is your n is even ke odd. Kalau your n is even, then it will result positive value. If your n is odd, then it will result a positive value of 1 for cos pi n pi. Okay, so you may simplify this. You may replace cos n pi ni sama dengan negative 1 power of n. And then again here sin n pi. Sin n pi definitely become 0. Sebab n is any integer number. Sin pi, sin 2 pi, sin 3 pi, sin 4 pi, 5 pi, 6 pi, or negative again negative pi, negative 2 pi, and so on and so forth will always become 0. So with that, the whole term in the second term here turn out to be 0. So apa yang kita ada sekarang? What we left with is, okay, what do we left with is 2 over n cube pi cube. Okay, and then we have 2l square n pi, and cos n pi we replace with negative 1 power of n. Okay, negative 1 power of n. So daripada sini kita boleh simplify yang ni jadi kuasa 2. So it seems that everything here is power of 2. Termasuklah 2 ni. 2 darab 2 is 2 kuasa 2, betul? So you can simplify 2 bagi cantik sikit. We have 2l over n pi everything power of 2 negative 1 power of n. So this is our coefficient for an. The coefficient for an. But this is not yet answer our kita tak bagi lagi jawapan for our Fourier cosine series, where this is only the constant. Okay, this is only the coefficient a not an. So the coefficient the Fourier sine series, dia punya jawapan then become, tahu dia punya fx then become a naught plus with the summation of this lah. Okay, so this one we have our a naught is equals to l square over 3, and then plus with the summation of starting from n equals to 1 up to infinity. Our an is 2l over n pi everything square negative 1 power of n cos n pi. Okay, cos n pi. Okay, cos n pi x over l. Okay, ni adalah jawapan akhir for our Fourier sine cosine series fx. Okay, remember this function is in a function of x. Fx equals to l cube over 3. Okay, plus we summation from n equals to 1 up to infinity. Ni lah 2l over n pi square negative 1 power of n cos n pi s over l. Okay, so you may stop here. We do not have to kalau nak expand pun tak guna, sebab we do not know what is our value of l for the time being here. Kalau kita tahu, what I mean by expand is ni, yang ni kita buat macam dalam bentuk tak ada jawapan pula saya tak bagi jawapan kan. Dalam bentuk yang macam ni. Okay, we extend the value. Before this we have the answer for this one kan, negative 1 over 3 sin x, something like that, sin x plus we 1 over 5 sin 2x and so on and so forth. But for this one, I reckon you don't have to expand like that, because we still have a variable l here. But if we do know what is our variable l, then you may expand the series for the first 3 terms perhaps. Okay, alright, so we're done with Fourier cosine series. Okay, so now we have done with Fourier cosine series and Fourier sine series. Then only we are able to find the Fourier series. Okay, basically Fourier series ni, as I said before, the combination between Fourier cosine series and Fourier sine series. So as you can see here, this one is the term for Fourier cosine series and the second part is the Fourier sine series. So kalau sebelum ni the formula banyak simplified from 0 to L, right? 2 times 0 to L because the function is, we find out the function is an even function. Right. Tapi that's not menjamin it's always become an even function and you can simplify it become 0 to L. So what I given to you here is the formula for the general function where fx can be even or odd, kita tak pasti. So then the formula is like this. But if we confirm that the function is an dia punya hasil multiplication of the two function here, fx darab dengan cos pi n n pi x over L ataupun fx sin n pi x over L ni will result an even function, then you may simplify it become 0 to L times with 2. Okay, my attention is here. Kalau you tengok A0 ni kan, beza tak dengan A0 yang kita ada sebelum ni? Okay, A0 yang kita ada sebelum ni, okay, as you can see here, our A0 that we have before is 1 over L sahaja, where the integration is from 0 to L fx dx, right? Okay, for a cosine series ni, 1 over L 0 to L. Tapi formula yang saya tunjuk just now, okay, tak boleh bergerak pula. This formula we have 1 over 2L negative L to L. Kenapa tadi 1 over L sahaja? Because that just now we know that the function fx is an even function because fx is equals to x square, right? So that's why kita tahu it's an even function. So that's why dia kita jadi 2 over 2L from integration from 0 to L fx is x square dx. So that's why lah dia jadi 1 over L sahaja, where the general formula is this one. Same also here, this one. So you may simplify, become 2 times 0 to L, provided you are sure that the integrand inside that you want to integrate, the function that you want inside the integration tu, yang you nak integrate tu adalah even function, then you may simplify to that. Alright, so hope I make yourself clear about that. Okay, so now let's proceed to example 6. Okay, example 6 ni the function find the Fourier series. Fourier series for fx equals to x square from negative L to L. Looks familiar? Of course. Sebab tadi pun kita ada function fx equals to x square untuk cari Fourier cosine series. As I said, sebagaimana saya dah introduce tadi, Fourier sine series is a combination between Fourier cosine and Fourier sine. So maknanya jawapan untuk example 6 ni adalah combination between kita boleh gunakan jawapan daripada our example 5 tadi. Okay, we do already have A0 and AN. Jawapan yang kita ada, the term, okay, or the coefficient for A0 kita ada, the coefficient for AN pun kita ada. This is from example 5. Okay, we just need to find what is BN, the coefficient for sine for cosine series. Okay, so the integration is we use the dia punya formula 1 over L negative L to L fx sin n pi x over L dx. So as you can see here, fx is equals to x square. Okay, x square is even or odd function. Okay, sine we know it is an odd function. So odd function x square is apa? Even lah kan. Even darab dengan odd will give us even ke odd? We give us odd function. Okay, tak percaya tengok x square darab dengan x. Jadi x kuasa 3. X square even kan? X is odd. So jadi x kuasa 3 adalah odd function. So using the property, kita tahu it will result this one is odd function and you are to integrate from negative L to L. So according to the property that we have before, okay, that property is still valid. This one. Integration from negative L to L fx dx if given the whole function here fx, kalau tadi bukan fx je lah, which is x square sine m pi x over L. This is represent the whole function. Is an odd function, then the integration will turn out to be 0. Okay, so you don't have to waste your time, then you just can say, you can just say simplify this become 0. Macam tu je. Tapi you have to make sure, you have, kalau dalam test or quiz or exam, you have to explain why it is become equals to 0. Okay, then you have to start to state lah, x square ni even, this one is odd, so multiplication of two function become, this two function will result in an odd function. So integration integration from negative L to L for an odd function will become 0. Okay, so sekarang ni kita ada all the three terms. Okay, we have all the three terms. We have a0, an and bn, and we know this one turn out to be 0 because our bn is equals to 0, not because of this, because of our bn is equals to 0. So here kita punya term will turn out to be, okay, our Fourier cosine series, Fourier series is actually exactly the same as our Fourier cosine series yang saya tulis jawapan sebelum ni. Cuma beza dia yang ni saya buat, dia jawapan dia kat sini dia buat 4L square, saya buat 2L everything power of 2, ingat dalam example 5 tadi. Okay, so this is our answer for Fourier sine, Fourier series, Fourier sine pula, Fourier series where our fx here, okay, fx is equals to x square. So you can say fx equals to x square is equals to this series, L square over 3 plus with the summation of n from n equals to 1 up to infinity 4L square negative 1 power of n over n square pi s square cos n pi s over L. Alright, so clear everyone? Okay, kalau you are clear with this for your classwork submission, and also I may consider this as for your revision for your test 2 next week as well, I want you to repeat this example 6, redo it again, okay, redo it again, especially on, okay, how you show, okay, tadi kan saya cakap okay, jawapan dah ada, cumanya I want you to show how you perform this integration by part. Macam mana you dapat jawapan ni. Okay, that is one thing for your classwork submission. And then another classwork submission is, okay, I want you to find, okay, I want you to find the Fourier series. Fourier series for fx equals to x. Fx equals to x. Sebelum ni kan kita dah cari, example 4 ni kita dah cari Fourier sine series. Meaning, you may make use of this for the Fourier sine series. You just have to complete the work or the solution by finding the Fourier cosine series. Okay, just campur Fourier sine series with the Fourier cosine series that you are yet to find. Then you will find what is your Fourier series, okay, for the function fx equals to x. So basically for your classwork submission, okay, classwork submission, okay, there are to find, okay, Fourier series, okay, find Fourier series for fx equals to x, and another one is fx equals to x square, both for the interval from negative L to L. Basically, I must say more than 50% the solution is already here. You just have to redo it again, and ada setengah yang you need to expand the integration and so on. If you understand this lecture very well, it won't take you a long time to solve that. Okay, just make use of the properties that we have discussed, especially on the even and odd. Then it will make your life very easy. Okay, so that's all for the first part of the video.